In section 2.3, we're going to be talking about linear functions and slopes, and our objectives are to be able to graph linear functions and to be able to write equations of lines. So let's start by just getting a general grasp of what we mean by slope. Slope is defined as the ratio of the vertical change to the horizontal change between 2 points. And here's just a few examples of where you might see a slope in a real world situation. Here we have an example of where you've got maybe a hillside with a slant to it. That would be the slope. If you look at the house, we can talk about the slant of the roof. That's actually called the pitch. And then here we have a downhill skier, and you can see that we have a very steep slope here that he would be following as he's skiing. One of the things we'll need to be able to do is to differentiate between our different types of slopes. So I went out to the internet and I found an example of something called a slope tree to help you maybe organize the way that you visualize slopes. So let's look at what a positive slope would look like. Notice that a positive slope is a line that is increasing as you travel from left to right. Then we have a negative slope. In a negative slope, your line is decreasing as you travel from left to right. Now, our last two slopes are actually slopes that students get confused all the time. That is the zero slope, which we have here. If we remember that our zero slope, or a slope that would be zero, would have a vertical change that would equal zero. So if we look at that line, there is no vertical change, so that would be 0 over, well, the horizontal change, there is a value for that. So there'd be some number there, but when you take 0 and divide by a number, you get 0. Now, in an undefined slope, our last type of slope, notice that what happens there is that we have vertical change, so we would have some number for the vertical change, but we have no horizontal change, so that would be over 0. Well, when you have a number divided by 0, that's always undefined. So an undefined slope would be a case where your denominator would be 0, and in a zero slope would be a case where the numerator would be 0. And in both of those cases, notice that you don't have 0 in both numerator and denominator. Now let's look at a formula that we might use to find the slope. Notice that we defined our slope to be the ratio of the vertical change to the horizontal change. Now remember that the word ratio is another way that we can think of as a fraction. It's a division problem. And we're going to divide the vertical change, which we sometimes refer to as the rise, by the horizontal change, which we refer to as the run. But if we think about points, let's say on the XY axis, and we've got 2 points, the vertical change is going to be the distance that the graph is going to rise, where the horizontal change will be the distance that the graph is going to run. So if we think about having 2 ordered pairs, let's call this one x1, y1, and this one x2, y2, then if I wanted to calculate the slope, the vertical change, the rise, would be the distance between the two y values. So it would be y2 minus y1. The horizontal change would be this distance, and that would be the difference between the two x values. That would be x2 minus x1. So this is a formula that we want to use for slope, and we usually use the letter M to stand for slope. Now let's take some ordered pairs and determine the slope, and let's describe what type of slope that the line would have. Is it positive, negative, 0, or undefined? So in our first example, we're going to subtract our 2 y's, and the order in which you subtract them doesn't matter, but whatever y you start with in the top, you have to start with the corresponding x in the bottom. So if we do 4 minus 1 in the top, since that's my 2 y numbers, then in the bottom, I've got to do 5 minus 8. Well, we know that 4 minus 1 is 3. 5 minus 8 is negative 3, but that would simplify to negative 1. Now, our slope is a negative number, which we know means we know that this has to be a decreasing line. So that's a negative slope. Let's look at our next example. So we've got the point 2, 2 and negative 2, negative 2. So again, subtracting the y's. So we'll do 2 minus negative 2 over, in the denominator, we're going to have to start with the x value of 2 minus negative 2. But 2 minus negative 2 is positive 4, and then the denominator would also be 4, which would be positive 1, which means we have a positive slope, so we'd have an increasing line. In our next example, if we subtract our y's, we're going to have 3 minus negative 4 over, subtract our x's, 9 minus 9. But 3 minus negative 4, that's 7. And 9 minus 9 is 0. Well, we just discussed that when you divide by 0, that's undefined. So that is an undefined slope. And if we remember from our slope tree, slopes that are undefined were vertical. So that would be a vertical line, which will be important that we recognize that. And then our last example, let's take our y's. So we'd have 5 minus 5 over 2 minus 7, but that would be 0 over negative 5. But 0 divided by a number is 0. And again, if we remember our 0 slope, we know that that line was horizontal. And that's important that you put that together. The slopes that are undefined are going to be vertical lines. Slopes that are 0 are going to be horizontal lines. Now let's take a moment and look at some terminology. Let's discuss what we mean by the term linear function. Well, just by looking at the prefix of our word, notice that we see the word line. And a linear function is a function whose graph is a line. Now, one of the ways that we can graph lines, and we'll talk about this later, is to look at what's known as the intercepts. And there are two different types of intercepts, but in general, an intercept is a point where a line is going to cross an axis. We call the x-intercept the point where the graph crosses the x-axis. To find that, we want to let y equal 0. And then the y-intercept is where we cross the y-axis. And to find that value, we'd want to let x be 0. Now, one of the things that we're going to do throughout this rest of this chapter is talk about equations of lines and then different forms of those equations. One of the most important ones that we'll use is something known as slope-intercept form, which is y equals mx plus b. You should have used that extensively in Algebra 1. Remember that your m is your slope and your b is your y-intercept. So that's going to tell you where you're going to touch the y-axis, and then m is going to tell you where you're going to move or how you're going to move with your rise and your run. Now we'll take a moment and write some equations of lines, and we'll also look at the graphs of those. So let's talk about, we want to write the equation of a line that has a slope of 4 and a y-intercept of 0, 3. So let's plot that to begin with. So if our y-intercept is 0, 3, then we're going to have a dot on the y-axis at 3. Then our slope is 4, so we would count up 4 and over 1. We want our slopes to normally be fractions. And we're not exactly on our grid. Now, we could also, instead of counting up and over, we could have counted down and then to the left 1. And that would work also. And now we can connect those points and draw our line. Now, what would the equation of that line be? Well, remember, our equations are, or one of the forms of our equations is y equals mx plus b. But we know all the information for that equation. Our m was given to us as 4. Our b is our y-intercept, and we knew that it was 3. So that's the equation of the line that would have this graph. Let's look at another one. What if we have a slope of negative 2/3 and a y-intercept of negative 2? Now notice this time they didn't give us our y-intercept as an ordered pair. So let's start at negative 2. And then if our slope is negative 2/3, we're going to count down 2 and over 3 and get another dot. Or we could count up 2 and over negative 3. And now I could connect those dots and find my line. Now let's write the equation of that line. We want to go in mx plus b form. So we could substitute in our slope is negative 2/3 x plus our b, which we know was negative 2. So b plus negative 2, or we could just make it minus 2. And that would be the equation of the line that would give you that graph. Now we're going to take a couple equations and we're going to put them into slope-intercept form, which again is y equals mx plus b. And then we're going to identify what's the slope and the y-intercept. So our first equation, we want to get the y by itself. So let's start by subtracting a 3x from both sides. Now, because the 18 doesn't have an x with it, we can't do anything to that. So I'm just going to rewrite this as negative 3x, because I want my x term first, plus 18. But I have 2y and I want just y. So I'm going to divide everything by 2 and get that y would equal, well, negative 3 divided by 2 doesn't simplify nicely, so let's just leave it as negative 3/2 x. And then 18 divided by 2 does simplify to 9. And now we can find our m and our b, which is our slope and our y-intercept. So our m would be negative 3/2, and our b would be 9. Let's try the next example. We have 2/3 x minus 3/4 y equals 12. And I want to get y by itself. So again, I'm going to subtract a 2/3 x from both sides. And that's going to give me negative 3/4 y equals negative 2/3 x plus 2. But I need to get y by itself. I don't want to divide by fractions. We've discussed that numerous times. What I want to do is multiply by the reciprocal. So I'm going to multiply both sides of this equation by negative 4/3. When I do that, on the left-hand side, I'm going to be able to cancel out my 4/3, or my negative 4/3 and my negative 3/4, because they're going to multiply together to give me 1. So I'm going to have y equals, and now I need to multiply these fractions together, negative 2/3 times negative 4/3, which would be positive 8/9 x. And then I need to multiply negative 4/3 times 2. But that would be minus 8/3. Remember, think of that as 2 over 1. Then we multiply numerators and multiply denominators. So now I can tell you that the slope of this line is 8/9, and the y-intercept is negative 8/3. Now we're going to take a few minutes to sketch the graphs of some lines. One of the ways that you can do that is to do just exactly what we did on the last example and switch our equations over to y equals mx plus b form. So let's start with that. In this first equation, I'm going to subtract a 2x and get that 3y is going to equal negative 2x plus 9. Then I'm going to divide everything by 3 because I want just y equals. And that's going to give me y equals, well, 2 divided by 3 doesn't divide nicely, so we'll just leave it as a fraction. Make it negative 2/3 x plus 9 does divide by 3 times. And so now I'm ready to graph. My m is negative 2/3 and my b is 3. So we're going to start at 3. And then I'm going to count down 2 and over 3. Put a dot. And now I could do that again, count down 2 more and over 3 more. And now I can connect those dots And there's my line. Now what about the equation of the graph negative 2x plus y equals 1? Well, let's add 2x to both sides because, again, we're trying to get y by itself. And that's going to give me that y is equal to 2x plus 1. And notice that I don't need to divide in this case, so I'm ready to go ahead and start sketching. So let's write down that our slope is going to be 2. And let's make that 2 over 1, and our b is going to be 1. So we're going to start at the y-axis at 1, and then we're going to count our slope up 2 over 1. And we'll do that a couple times. We could have also gone backwards and went down 2 over negative 1. Do that a couple times. And notice that I have several points now. And I just want to connect those dots in a line. And there would be the graph of that equation.